Welcome to you all. Have a seat if there's some left. It's a full crowd, so it's really nice to see you all here today. The mic does not, now it should be, right? Yeah, okay. Thank you all for coming to my talk, TypeScript Inaccuracies. Today I will be exploring ways in which you can get more accurate types in TypeScript. And before I start, a little bit about myself. I've been around, graduated in '98, computer science, and then in 2000 I became a Java backend developer. Actually, I never really liked frontend. I was always hiding from JavaScript. But then in 2012, something happened. I was working at a client, and we had this solution generating JavaScript code out of Java code. But it was too limited, so I had to stop hiding from JavaScript. This is actually a blog post. And we began using AngularJS at the time. But being a backend developer and liking types and also type safety, I was always looking for ways to introduce some type safety. So I was fiddling around with JSDoc at the time. TypeScript was there already, but I wasn't using it. But my IntelliJ ID would give me some warnings. But it wasn't until 2018 that I really started professionally using TypeScript. And then I always noticed actually that TypeScript wasn't made a clear distinction between what JavaScript is and what TypeScript is. So I came up with an analogy called yin-yang. And in 2020 I had this online lunch meeting. And last year I did the talk and to explain how TypeScript compares to JavaScript. Today, of course, is Frontmania, and actually, after Frontmania, I will be becoming a trainer as well because I developed the whole training, beginner's training in TypeScript, based around the principles of yin-yang. Today, the agenda. I will be talking about inaccuracies in TypeScript and what kind of flavors you can have in that. Also go into the TypeScript reset library and how it is implemented using declaration merging. Of course, we go into how to create more accurate types, because that's the whole idea for today. We do some type programming. That's the advanced way to get more accurate types. There's also some simple ways as well.
You're speaking out of your eye.
Yeah. Yeah? Okay. Out of my eye. Okay. Okay, that's good. This is much better, by the way. We'll do some live coding, see how that works out. And last but not least, I will go into some coding conventions and some personal recommendations. So before I really start, I was a bit too ambitious, so I probably don't have time for questions. But I'm around the whole day, so and also directly after speaking. So, and everything is on GitHub. Once again, the QR code. The last slide is also the QR code as well. The slide deck is on GitHub, and also the live coding sources, including the in-between steps. I will later show you how I did that. So you can reproduce if you like and see what I did during the live coding. Also notice that type programming is quite advanced and takes some time to get really used to, and maybe it's also a bit too advanced to do always, but we're just scratching the surface what's possible today, just to keep things simple. And it's totally fine if you're a bit overwhelmed. It's a totally different new subject we're talking about. So talking about inaccuracies in TypeScript, a type can be too broad given a certain situation. It could also be too lenient, meaning that it's not fully type safe. And of course, a type can be plain just incorrect. And what do I mean with too broad? If I have this little function that has an argument with a nullable string, and it maps to a nullable date, then actually the inferred type is a union type of a nullable date. But even if I pass in a string and I know for sure that I only could get a date back, I'm still confronted with this union type. By the way, during the talk, I'm using this caret question mark 2/ comment thingy. But this shows exactly the same as you would normally see when you hover over the element that I point at. And also during live coding, I have a plugin for that. and also null, I'm getting the same union type. So even actually the type invert type is too broad, but even if I would specify it myself, I could not fix it unless I do something else, and I will later show you how to fix this. To illustrate it, what if I use this function and I know for sure that the string is not null, then TypeScript will still bugger me. And I could say, okay, just slam in a non-null assertion and be done with it. But preferably, I wouldn't do that in production code. So yeah, then I tend to just make a conditional expression, which is a bit a bummer because yeah, I really want it to be automatically, to be honest. And there's also two lenient types, and we all know the any type, right? Basically, any type disables. It is problematic because it disables type checking. But there's also an irritating part about any type as well. It's also leaking. So it might also have impact on portions of your code that you don't expect. Check out this article. So you want to minimize any as much as possible. And if you want to use any as the top level type in TypeScript, then there's a modern alternative, which is unknown, and that is fully type safe. Also, any occurs in building typings that are shipped with TypeScript. So actually, the JSON parse has an any return type. This is fixable, but it's not fixed by TypeScript. I will later on describe how. And also, in order to get a grip on any, there's this nice little tool called type coverage, and it will spot all the any in your code and everywhere where it leaks to. So it's a command line tool so that you get a lot of information, but there's also a TypeScript language service plugin, and then it will work just like ESLint directly in your editor. And also, being coverage, there's also an HTML report, just like your unit testing reports. And we all know incorrect types. And nowadays it's less and less a problem because a lot of code is nowadays written in TypeScript. So then the typings are generated out of it, the d.ts files. But we still stumble into situations where you have to use a types package. And then also when you're using a separate package, the version could also become out of date because you forgot to bump it. Or sometimes you just have a major bump and the new major version is written in TypeScript, but you're still using the old types package. Been there. So yeah, sometimes it's self-inflicted and sometimes it's just, yeah, it's troublesome. And the whole incorrect types, of course, it can lead to confusion because you expect what you see in your editor, in your TypeScript to be right? And you waste a lot of time, and in the end, you probably will fix it using as any or something, but you prefer not to. But or you just fix the types. You could do that as well and submit a pull request. That would be nice. I have to admit, I don't do that so often. When it comes to the annoyances in the building typings, there's the TS reset library. In the TS reset library, it will fix the JSON parse issue. So normally you will get this any, but if you do a side effect import of TS reset, then you will get unknown. And also it will fix more situations. This is a quick way in order to, using a Boolean constructor with a filter on an array is a nice little way to filter out truthy values. Or to filter the truthy values, filter out falsy values. And you want your type to also be adjusted, so there shouldn't be an undefined and null inside. And normally it will not be the case, but you do this side effect import and it will be the case. And actually using TSVZ is not really nice, but only use it for applications. Why? Best check their website. And there's also more fixes they made in TSVZ as well. So declaration merging allows TSVZ to override the building typings. And to demonstrate it, I will actually do some live coding using VS Code. And also this /# plugin for that. And later on also show you how you could do some simple unit testing of your types using expect type. So everything is in GitHub. So declaration merging will actually merge multiple definition of an interface with the same name. So if I have a second box interface, I already have a box interface with a width and height, but I introduce another one with scale, notice that indeed, I'm actually getting a compilation error because it lacks expects a scale. Could then fix that, and then it should work. Yeah. Coming back to JSON parse, let's do the TSVZ thing. And on the global scope, I'm also declaring my own JSON interface, and now I'm having an unknown return type. Actually, I'm not overriding, I'm overloading. You can really show it like this, because it says one of two. This is my definition without JSToc, and this is the original definition. So that's declaration merging. And of course, we often need to register matches for our testing framework. Down here we registered our own matcher, but TypeScript also needs to be aware of it. And you can do this in a similar way. And on the global scope, inside the jest namespace, I'm also declaring the matches interface and adding a new method to it. So this is how a declaration merges. A quick demo. Hope this works. Yep. So more details about declaration merging, check out this link from the TypeScript handbook. So, what about more accurate types? We already seen declaration merging, but we can also use generics, also optionally with the key-off keyword. Let's see how that works. Let's say, for instance, I want to create this getter function that are passing an object, and the second argument is a key from a property. So I then declare it with a type parameter and specify in the extends clause that it is an object, and also the key. I'm using the key-off keyword from TypeScript to indicate that the key should be a string literal type from one of the keys of this particular object. So if I then retrieve a particular key, notice actually that the second parameter also is type checked, then I'm getting also the inferred type back for this particular property. But notice if not all properties have the same type, there's actually a bug in my function over here, I'm getting a union type back. I'm getting actually the combination of the types of all properties. As it turns out, and this is why I made a slide of it, I stumbled on this as well, you also have to introduce a type parameter for the key. Do this and notice now that if I want to retrieve the second argument, then actually I'm getting a specific type for a specific key. But this is not all. Key-off and generics is nice, but key-off is simple, it's just one level. What if I could have a dotted property path, and then it would also work? So later on, I don't know if I have plenty of time, we'll definitely show you the sort nested property. But in the live coding sources, there's also the implementation of the getter as well. And actually do the type programming for that. live coding later on. So, generics and key-off also allow us to have more accurate types, but there's also function overloading. And actually for function overloading, you can use it to get a different return type depending on a different argument type. Also notice that you have to use function declaration. This will not work with arrow functions. I know you all like your arrow functions, but it doesn't work, unfortunately. So we rewrite your code to a function declaration, and then we prepend it with overload signatures, they call it. And the overload signatures will then act as a public API for your function. So if you call it with a string, you get a date back. If you call it with null, you get a null back. And now we fixed our problem. And we're having accurate return types in this case. Also check out this link from the TypeScript handbook about further description of function overloads. So we've seen function overloading, but today I guess we're all here for type programming. So let's nerd out a bit. And type programming is a bit like programming, but it is in the type space. And actually, TypeScript makes a distinction between the value space and the type space, but I won't go into that much today, but there's a difference. And to do type programming, you need type parameters, generics, and it also allows you to do custom type inference, because normally type inference is done implicitly, and also there's a built-in set of rules on how TypeScript does its type inference. But now you can do your custom type inference. You do this by creating types from types. And one easy way to get into type programming is just use utility types, which is just like helper functions. And there's the built-in types like partial and required. Now partial makes all your properties optional, and required does the reverse. It make everything non-optional required. But the built-in types especially become really powerful if you combine them. Let's say I have a user and for some reason ID is optional. Then I can do this, which is kind of complex to be honest. But this will make ID required and the rest will keep it as is. And using an intersection to include the two types. And then when I hover over it, I get this unreadable. But I will later on show you a way to fix this. There's also third-party utility types. A popular one is Typefast. And in Typefast, I could actually fix this earlier problem. Just wrap it in, simplify, and then I'm actually getting a type back that I can read when I hover over it. But there's also set required, and that allows me to make one or more properties. If you want more than passing a union type, make them required. That's nice quite a nice stuff inside Typefast. Just check it out. And to do type programming, you are creating types from types in various ways. We've seen generics, and there's also pre-written utility types, but there's also a type of keyword, and there's also the index access type, the conditional types, the map types, and the template little types. I try to give you an overview today of them all. Let's see how that works with the time. Type of, it actually retrieves the type of a variable or property. Actually, this variable property is in the value space, and the type of is a keyword. You want to extract it and get it into the type space, basically. And it's often really useful if you have a type argument, and you want to, as an argument, you want to use a value. In this case, I have a function, and then I want to use the utility type return type, but it doesn't allow me because it says, oh, you're referring to a value. Do you want to use it as a type? This is one of the last few occasions that actually TypeScript will give you a meaningful error message. So just create it in type of, prefix type of, and then it will work. And now for time, I decided to do this all at once using some live coding. So switch off to live coding first. And I should have gone back. Why didn't I do it? Oh yeah, there I am. Yeah. So first I do a quick demo about indexed access type. It says index type, access type. It should be indexed access type. And notice that it works like this. I just first specify the type, and then square brackets, and then the name of the property as a string literal type. So in this case, it complains because an empty string is not a valid property. Also, age is not a valid property. But if I pass in a valid property, then notice that you're getting the type of the property back. If you're passing multiple properties with a union type, then I'm getting the combined type also as a union type. So it could be a string or a number. If for some reason I also pass in an optional property, I'm not only getting the type back, but also undefined. Instead of just explicitly specifying all the individual properties, you probably use key of, and then you get the same result. Key of is the same as all the individual properties. There's also conditional types. And conditional types is like these ternary conditional expressions, just like in Java. Under the hood, they work a bit differently, I must say. So I want to check that dog is indeed an animal. But if you look at the interface definition, it should be. But I want to have the type true if that's the case. So just create a conditional type. So dog extends animal. Extends basically means is assignable to. And if then I would turn true, and then otherwise I would turn false. Well, of course this works. Doesn't necessarily need to be a Boolean. Could also be anything you're returning. So in this case, I will be returning a string literal type. Also, conditional types, they allow you to also do like pattern matching in its extends clause, and you can then use the infer keyword to extract a certain type out of it. So this little utility types will flatten the type. So if it's an array, then it will return the item of the item type of the array, and if it's not, it will just return the type as is. So first off, I always type this incorrect.